Lesson 7-2, dividing monomials. Our essential question is, how do you divide monomials? We have three new properties today. The first one is called the quotient of powers. Remember that the word quotient means division. So what you see is the division of powers. The division of powers. Remember, a power means you have a base with an exponent. So what I want you to notice about this property is that as long as the base stays the same, when you're dividing powers, you subtract the exponents. You can subtract the exponents. So the base has to be the same. So that base, by base I mean the letter A. So base must be the same. And if it is, you can subtract your exponents. The next property is called power of a quotient. So we have a power or an exponent on our quotient. So this is very similar to the one where we had power of a product. So what you see is that you distribute the exponent that's outside of the parentheses to everything inside. So distribute the exponent. If the terms that are on the inside already had an exponent, you would have to multiply it together. And then our last property is called the zero exponent property. Anything to the zero power equals the number 1. It's kind of like an identity property.
Please excuse this interruption. China Hardy, please come to the main office. China Hardy, please come to the main office. Thank you.
Okay, let's use these new properties. I'm going to show you expanded form because that is going to explain to you, hopefully, why the shortcut rule said we could subtract our exponents. So I am going to expand x to the 7th power and y to the 2nd power, x to the 6th power, and y to the 3rd power. Okay? So, when you're dividing, we know with reducing fractions that if you see the same factor in the numerator and the denominator, they cancel each other out. So x divided by x would be 1. So all of these x's are going to cancel each other out. So are some of these y's, because y divided by y would be 1. Now take a look at what I have left. What I have left is x divided by y. X divided by y. So that is simplified. Simplified. Now, this example isn't the greatest when it comes to subtracting exponents for the shortcut, just because we haven't learned what to do about negative exponents yet. So if I subtract these, I get x to the 1st power, and I get y to the negative 1st power. On day 2 of this lesson, you will learn that y to the negative 1st power means that that y is in the denominator of your fraction instead of your numerator. The next example, negative 8, x to the 5th, y to the 8th, z, and then we've got 16, x to the 3rd, y squared, z to the 4th. If I reduce the fraction, negative 8/16, 8 goes into 8 once and into 16 twice, so I would get negative 1 over 2 for reducing that fraction. I have 3 x's that will cancel each other out. I have 2 y's to cancel each other out, and I have 1 z to cancel out. So now take a look at what is left. And in the numerator of my fraction, I have x squared, and I have y to the 6th. In my denominator, I have z to the 3rd. So that is my answer. What's important to recognize is that the numbers 8 and 16, negative 8 and 16, you treat those like you treat a fraction, like a fraction that has integers in it where you can reduce it by looking for what they have in common. So I just factored out of both of those their greatest common factor, which was 8. The variable part, I am just expanding it, and then I'm looking to see how many I can cancel out and what I've got left. Now our shortcut, when we talk about our shortcut with subtracting our exponents, that isn't going to help us out with the negative 8/16. X to the power of 5 minus 3, I'd have y to the power of 8 minus 2, and then z to the power of 1 minus 4. So I would still have to reduce that fraction to negative 1/2. And then I would get x to the 2nd power, y to the 6th power, and z to the negative 3rd power. Again, that means that the z is going to be on the bottom of your fraction in the denominator, because that's what negative exponent means. Our next examples. Now we're going to need to do some distributing here. So it's very important that you distribute this exponent to everything in the numerator and denominator. So it is going to be 4 to the 3rd power, c to the 9th power, d to the 6th power, and divided by 5 to the 3rd power. Remember, when I distribute those exponents, I multiply them times the exponent that was already there. Now, 4 to the 3rd power would be 64, and 5 to the 3rd power is 125. So that would be my answer in simplified form. I could distribute this. I could also expand it. So if I expand it, I'm going to take this 4c to the 3rd d squared divided by 5, and I am going to need 3 of them, because my exponent outside of my parentheses is 3. Okay, so hopefully you can tell by looking at these when I multiply my fractions. 4 times 4 times 4 is 64. 5 times 5 times 5, that's my 125. And then look at how many c's I'm multiplying. So c to the 9th, and then d to the 6th. So you can see where this answer would come from in expanded form. This next one I'll expand first. So I need 2 of everything. So negative 3x y to the 3rd over 2x to the 4th y. So it would look like this. I need 2 of them because it was being squared. Now, before I multiply them together, I notice I can do a little bit of reducing. So I can cancel an x and a y on each of these first. Then I can multiply together. Negative 3 times negative 3 is 9. 2 times 2 is 4. And then take a look at how many y's I have in the numerator, y to the 4th, and how many x's I have in my denominator, x to the 6th, to get my final answer. So this is simplified. If I instead wanted to distribute up here, I am going to have to distribute this to 6 different things. 6 different things. So take a look at what that means. If I distribute, the negative number I had to put in parentheses because it makes a difference. Okay? Then if I was going to try and do some subtracting with my exponents and do some reducing, well, negative 3 squared is 9. And 2 squared is 4. If I subtract my exponents, I get x to the negative 6, x to the negative 6, and then I get y to the 4th. So again, that negative exponent means that it's on the bottom of the fraction. So I really prefer expanding on these instead of doing the subtraction with the exponent rules. Okay, now a little bit easier. Anything to the power of 0 equals 1. So all of that stuff that was in the parentheses was being raised to the power 0. So the whole thing is just 1. The whole thing is just 1. On the second example, though, the 0 power is only right here on the m. So that part turns into a 1. So it doesn't affect the variable n. End of the third. One end of the third is just end of the third. So really, if I expand this one and then cancel out 2 of the ends, my simplified answer is just n. Just n. So m to the power of 0 is 1, or this whole entire thing to the power of 0 is 1. It's just like an identity. If you play around with your calculator, you could put in something really big. You could put in a number like this, and then put to the 0 power. It's going to give you 1. So you think about that 0 power as if it's not that number at all. So if you have 0 of them, you don't have any. So you've just got the identity number 1. 2 more. This first one, hopefully you look at it right away and you can tell it equals 1. This second one, x to the 0 power is 1, so is y to the 0 power. Multiplying by 1 doesn't change anything, so I am just going to eliminate that part and then expand this to simplify. Now, 3 z's cancel out, and that's it. Nothing else cancels out. So I have y to the 4th over x squared, z squared for my final answer. You should be able to write your summary now. And here are your homework problems for day 1.